have text and pictures and such on them. HTTPS is used for web pages where you want to encrypt the data. And this is a common misunderstanding of HTTPS fostered by crooked retailers, such as basically every bank in America until about 5 years ago. The only thing they wanted people to know about HTTPS was that it encrypts the data. But it also makes sure that you know who you're talking to, which is probably even more important than encrypting. It's close to it. And that function only works if the entire page is HTTPS. There is a security flaw practiced by every bank in America I can find except Citibank until about 5 years ago. But they're now better. But if I go to like Wells Fargo, then Google is secure all the time, which is new even for searches. But if I go to Wells Fargo, notice it's also secure, HTTPS. This is a very good idea. However, this is new. And in the past, until just a couple of years ago, Wells Fargo and all the other banks I've tried in class, students were just calling them out, would have an HTTP page for their main page, and they'd have a login form, and that button would be an HTTPS method. And I complained to all those banks after a classroom discussion and demonstration in class, because that's a terrible idea, because if the whole page is not HTTPS, you don't know who it is. And you can't see anything to tell you that button is secure, so I can make a duplicate page that looks exactly the same, and people will log in. The page where you log in has to be completely HTTPS, or you have no assurance where you're going. And I complained to all the banks, and I got a canned answer from all of them. There was a standard answer. In fact, I might still be able to find it on the web. This is one of the things to make you feel kind of cynical. Why this is secure. There. This is what it used to be. All you need to Google this. There was somebody wrote a standard. Yeah, there you go. Here's people blogging about why this is secure. Yeah. And you'll find this everywhere, all over the web a few years ago. Why is our online banking secure? And they have a lie here, which is, I'm not finding the exact lie that they told me, but I get the same answer from all of them. Obviously, it was written by a prominent industry lawyer saying, SSL encrypts your data so everything is fine. And I would answer back saying, no. I asked, well, how do I know I am at your site and not a phishing site, which is the #1 risk your customers experience? So why do you answer me telling me it's encrypted when I'm at your real site? And then I get no answer at all from them. But the point is, it was not their problem. If I send you an email pretending to be PayPal, and you click on the link and go to some site that is not PayPal, but looks like PayPal, PayPal is not legally liable for the fact that you hand those clients your name and password because you never really went to PayPal. So the fact that they put up a site that's easily spoofed is not, or at least wasn't, until a few years ago, considered to be their problem legally. Anyway, now some rules have changed, forcing banks to be more secure, and as you see, they are. This is now the way it should be, secure right from the start. Yeah?
I was told to look for the lock, but also that it should be green. But I've noticed some of the sites it's not green.
It doesn't have to be green. There's two kinds of security. There's two kinds of web. See, one kind of, there are different kinds of certificates. And what happens is, if you get a normal certificate, it'll typically turn blue. And that is exactly as cryptographically sound as any other. The math is the same. The only difference is how much human detective work went into selling you a page, selling you a certificate. The green website is what they call more enhanced security. They charge a lot more money for it. And the reason they do is that supposedly they do human research to find out if this is really a legitimate company. And if you look at the rules, it can't be hosted in a suspicious country that has known to host a lot of malware sites. And you have to have a real business license and stuff like that. Supposedly that's what you're paying for with the green certificate. And supposedly you're supposed to trust it more if it's green. That is the idea. Some people think this is just a cynical marketing ploy by the certificate salespeople to make more money by selling snake oil. But that is what's supposed to happen. It is the same mathematics, the same length of the key, the same protocols. But what's different supposedly is they actually researched this website to make sure they're not crooks. If you see the green, whereas if it's blue, the only research they did was make sure the check cashed.
And if it's no color?
Well, there's no color in most modern browsers. It means it's not even secure.
Even though it has a S?
No, I don't think there's any that have the S that don't have any color these days. Maybe I'm wrong. Can you think of one?
I was on my Mac. I don't know which side I was.
See, it depends on what browser you use. And so here I'm at Yahoo, and this is not secure at all. If I go to sign in at Yahoo, it better be secure. And it is in green. Yeah.
In Firefox, if it's not using the auxiliary application stuff, it won't go green.
So, and it doesn't turn blue either. It just shows the catalog with no color.
Yeah.
Yeah, it's Firefox. Okay. That's the problem. The browsers have not standardized on how to display this, and some people even started taking away the padlock now, because a lot of phishing site authors figured out just put a padlock up there to try to fool you. And so this is, and studies have shown that 99% of users have no idea what any of this means anymore at all. They just look at like this part here that says Yahoo, and they figure it's the right page, because what else are you going to do? And most people are surfing on phones and stuff, and they don't even show you the address bar. It won't show you anything. So this is a pretty big problem in the world, and really DNSSEC is probably our best hope of fixing this. If DNSSEC was being used, which probably won't happen for another 5 to 10 years, that every time you see yahoo.com, that will actually be cryptographically verified that you're really talking to yahoo.com. And that would go a long way towards fixing the current situation where you're banking and shopping and sending personal messages, and you really never know who you're talking to. Anyway, so that's HTTPS. It's secure, it encrypts things, and it also gives you some guarantee that you're talking to the person you thought you were talking to. A third party has vouched for them. FTP lets you move files up and down to stored sites on the web, but it's also insecure. The correct use of FTP is just to put up a page of something like software updates that you want the whole world to get. Although it would be much better to just make a web page use HTTP. There's a thing called named FTP where you actually put a name and a password into FTP, which is used by almost everybody, including major people like Yahoo to update their website. And this is terrible because it's plain text. There's no encryption of the password at all. But even a couple of years ago, somebody put a malware on a major web server and they did all the credentials for all the major websites with their FTP passwords. FTP is a snare and a delusion. Your users have to remember a password and they imagine they're controlling access to it by using a plain text password that anybody could steal any time. This is the opposite of security. Real security is when your authorized users can do their work and the other authorized people can't get in. But irritating your authorized users with a worthless security measure while letting the bad guys get in, that's anti-security. And that's what FTP passwords are. And for that matter, web passwords. You make your authorized users have to type in this password, but use a protocol so lousy that the bad guys can still get in. That's the opposite of security. Less available for the good guys and not any less available for the bad guys. Anyway, SFTP is the replacement, secure FTP or FTPS. These are two different ways of encrypting FTP, make it much safer. Trivial file transfer protocol is used to upload software into routers and phones, and it has no password at all. Just transmits data automatically. And Windows 2000 used to have this on by default, so viruses could just crawl the wire into your machine without any prompt or anything, and that's why Microsoft was compelled to add a firewall to Windows XP to stop that. Yeah? They're not exactly the same. They both accomplish the same goal. They both add encryption. They use different kinds of encryption. I think the first one uses SSL, and the next one uses something different. I'm not quite sure what. The first one uses SSH, and the next one uses, I think, TLS. So a telnet is used to send command lines to a command line application like a Linux server or a router, where you type in commands. It sends every character in a separate packet, one at a time, with no encryption, because it was originally designed to be used to connect a terminal, which was just a typewriter, to a computer that was a mainframe in the corner down where you see the wire that was only 10 feet long. That's what it was for. And then it was ported to the internet by just putting each character in its own IP packet with no encryption, and it's still being used that way. And it's, again, a terrible thing. Every company should block Telnet and FTP at the firewall and tell anybody who's still using it to shape up or quit. Because it's ridiculous. They all send plain text passwords on the wire, and there's no excuse for that. This was all solved 30 years ago. People still haven't bothered to learn better. And I must say, when I taught the Cisco curriculum 2 or 3 years ago, all the Cisco manuals have a sentence in the beginning that says, of course you should use a secure protocol, and all the hands-on projects people really use tellers. So you don't learn to use the secure protocol, so people go on the job, they pull out their textbook and their homework, and they do it that way, and they do it in the insecure way that's been out of date for 30 years. So, you know, just like if you take a programming course, and you take the homework where you got an A, and you put it on the company server, you think you're doing the right thing, but you were not taught to write secure code, so you're putting more insecure code on the web. It's unfortunate. Anyway, SNMP is a management protocol used to control routers and switches and to get information about traffic flow and such. And also, SNMP, the most commonly deployed version, is a plain text protocol. It sends passwords called user strings and community strings in plain text all over your network. There is a later version of it that encrypts that stuff, but almost nobody uses it. DNS resolves alphabetic names to IP addresses, and again, without any encryption and without any authentication. So you can lie about a DNS resolution and people will just believe you. If I just tell machines Yahoo is over here and broadcast it on the network, they will go there looking for Yahoo. Yeah.
Does DNSSEC solve that problem?
Yes, that's the problem DNSSEC solves. DNSSEC requires you to have a cryptographic signature on your domain, and it checks to see if it's true. And I can't just put up a server and lie about your domain because I won't have the right signature. That's exactly the problem it solves. And after that, browsing will be much more secure. At least in theory, nobody knows in practice because DNSSEC is just in its infancy and nobody's using it yet. No browsers support it yet, and only a few of the most forward-thinking domains have it. So even if your browser didn't support it, all your browser would ever tell you is there's no DNSSEC information on this website, so what good would that be? But in about 5 or 10 years, probably, it'll become the standard, like IP version 6. So yeah, more about them here? No, okay. So yeah, more details coming up about them when we get down here. So HTTP is not encrypted, but normally you don't care for normal web pages, it's like on an advertising page. HTTPS is encrypted and goes on 443. It's really TLS these days. Almost nobody's still using SSL. That was the earlier version designed by Netscape. So FTP has 2 modes. The active mode uses these parts 20 and 21. The passive mode uses a random high numbered port, and 21 for control, which turns out to be another more subtle security problem. Firewall administrators have to let all these high numbered source ports through in order for that kind of FTP to come through. So it's, in a few ways, FTP is an inconvenience for a serious problem for network security, and nobody should really be using it anymore, but it really does. There's SFTP and FTPS. There you are. First one's over SSH, next one's over SSL. So it's using different ports. They both accomplish the same job of encrypting your password and all the rest of the data, by the way. So if you download stuff, you're not just spraying it to the whole world. TFTP has no authentication at all. There's no password required, and you cannot put one on. It uses UDP. TFTP actually had an entertaining bug in its early version. The RFC actually said that TFTP packets had to be followed by an acknowledgement packet, and even the acknowledgement packet had an error message had to be followed by an acknowledgement packet. And so if you work until the first error, and then you'd have an endless chain of acknowledge, flooding the wire. Because even the acknowledgement packet had to be acknowledged in that case. It was an error in the protocol. It's been fixed long ago, of course. So we talked about Telnet. Port 23, and SNMP, they call these things traps, the signals notifying systems, time to change a firewall rule, time to tell me how much traffic's been passing through that router. And it was SNMP version 1 and 2, sent the community strings in clear text. There is a third version, which almost nobody deploys because, of course, you could only upgrade to the third version after you replace all of your old network devices that are still using SNMP 1 and 2. And if you buy a normal name, you did not have a number, you name it like server 1, bedroom printer, something like that, and you refer to it by that name on the network. And that is called a non-routable protocol because if I call something server 1, a million other people also call their thing server 1. So when you actually make the internet and connect the LANs together, this kind of naming system doesn't scale. Now there's no way to tell which server 1 I'm talking about. So anyway, but NetBIOS is still used locally for file shares and printer shares in Windows. And it uses ports 137, 138, and 139, TCP and UDP. And a lot of vulnerabilities involve attacking those ports because this is really old legacy code with a lot of problems in it. LDAP is used to transmit directory information over a network. So you can send a query to a server saying, find out information about this object, and you can send an answer. You could use something like SQL, but LDAP's been around longer. Lightweight directory access protocol, and it has a way of sending a request for information to some central point and getting directory information back. And this is used by Microsoft's Active Directory. Originally, Novell owned servers. Novell were like 90% of servers up until sometime like around 1991 or so. And then Microsoft moved in and wanted to improve their domains, Windows NT domains, to kill off Novell and take their market away. They tried to buy the entire company, Novell, and Novell refused to sell. So they bought the developer of Novell Directory Services, and he jumped ship and went to Microsoft and rebuilt it for them, and that became Microsoft's Active Directory, and they did eat Novell's lunch, and Novell dwindled down to whatever they are now, 1% of the market or something, and Microsoft won. And it's the same thing. If you put something in a room like a printer like this, and I want the whole company to be able to print on this printer, and then I do something like move it to a different room, instead of having to go to every desktop and change the printer shortcut, point to the new printer, I just change it once on the domain controller in Active Directory, and every time anybody prints, they ask the directory, where's that printer? Okay, now send it there. This is much better. And that's why they call it Active Directory. You can move things around, you have one central point of administration for everything on your network. Of course, that also means if your domain controller goes down, your whole network stops. Therefore, you should never have only one domain controller. I mention this because I've had students come up to me after my Windows classes and say, oh my God, our company's running one domain controller, we never knew we shouldn't. And I know big companies like PricewaterhouseCoopers actually ran that way for years with one Windows NT 3.5 domain controller. This is a complete violation of every Microsoft best practice. You need two domain controllers because if one goes down, all work stops. You need two, one to back up the other, or more. Anyway, there's an unencrypted and encrypted version of LDAP also, although I've never heard of anybody using the encrypted version of LDAP. That would be nice. Kerberos is the system that lets people access network resources that require authentication. They get, when they log in with a name and password or whatever system you're using to authenticate them, they then get a ticket, branding ticket, and they then have the right to print tickets, digital tickets, which will give them temporary access to a shared folder or printer, good for use typically 10 hours. And so they, that's how it works. And this is what Windows domains use, and some Unix environments on port 88, Kerberos. Yeah?
Somebody is using like a sniffer and they catch the ticket, they can use it?
No. They thought it's got a special signature that's tied to something on your machine, so you can't replay it.
MAC address?
No, it's something more complicated than that. It's actually pretty complicated back and forth, but they didn't think of all that. You can't, tickets expire and you can't copy them and you can't forge them very well. It's very clever. In there ultimately is your password, but it's all scrambled in a way that's almost impossible to get back out. So Kerberos is really quite well played. Guys at MIT really put some work into Kerberos, and I've never heard of any serious Kerberos vulnerabilities. This is why I got really upset when I taught a firewall class a couple of years ago, and the textbook said Kerberos is not recommended because it transmits passwords in plain text. And I complained to the author. I said, what's wrong with you? The whole point of Kerberos was not to do it. He said, you've got to read the link. It's true, and it is true. And I mentioned this because this is a security problem. No matter how beautiful your math is, you have to take into account the fact that people are stupid. So Kerberos scrambles your stuff into these tickets that are essentially invulnerable. But what happened is when people first tried to use Kerberos over the internet, there was something in the way. There's something, so they sold devices to put on the edge of your network so you could have your remote users authenticate with Kerberos. And what that device did was people would go to a hotel room, log in, it would send a plain text password over the internet to that device, which would then scramble and make a Kerberos ticket. People sold these things and installed them, and then came out the scandal saying, don't use Kerberos, it sends your password in plain text over the internet. You wish it did. Anyway, it's not Kerberos that did that. It's because the actual implementation didn't turn on the Kerberos for the most important link. And this tends to happen over and over and over again. You have, like when people upgraded from Telnet to SSH, the early open SSH has buffer overflows, so now people just take over your server. You're worse off than you were with Telnet. This is, the protocol is fine, but the implementation may contain stupidity. Anyway,
what is a KDC in Kerberos?
The what KDC?
Yeah.
Yeah, key distribution center. It's one of the servers. You have to have a key distribution center and then a ticket granting ticket. It's really pretty complicated. There's quite a few encrypted messages flying around, but it's well thought out, so nobody can get your password and nobody can get in that shouldn't be getting in. Yeah.
So for Kerberos to not send your text over plain, so you can connect to it like a VPN?
Yeah, you could connect over VPN. That's what became the modern solution for this. If you travel to a hotel, you should use a VPN and then encrypt it with a protocol designed for that. For some reason, people don't use Kerberos over wide area network lanes. I think all these back and forth messages aren't optimized for that. So. But I don't really know exactly why, but I do know it is not common to use Kerberos directly from your hotel room. You typically use VPN. And now Microsoft has a thing called direct access for Windows 2008 to 2012 domains, where you go to your hotel room and you log in and it automatically connects you to your domain as if you're solo. But it does it through a VPN. All right, SQL Server is enormously important and a high-value target from hackers all the time, because SQL Server is where you store your structured data, and your structured data is typically credit card numbers, passwords, account numbers, employee email and addresses, and all the goodies that you want to protect the most. Like everything you told the college when you enrolled here, you had to give them your social security number if you're a student, worker, and you had to give them your name and address and your phone number and all that jazz, and all that stuff is stored in your database. We use Oracle, but most businesses this size would probably use SQL instead. Anyway, SQL is the Microsoft product. SQL Server runs on Windows Server, and it stores all that data, and then it hands out the data as required when it gets queries from other computers that want to get some of the data. So this is a high-value target. One common way to attack it is SQL injection, which I think we talked about before, and there's more coming. SQL injection is the #1 way data is stolen. Something like 85% of all stolen data has gone to this one problem, SQL injection. It is the one most important security problem in all web databases. More important to fix than all the rest put together by far. And about 11% of websites are still vulnerable to SQL injection. Which means you can just open the login page, type in a few characters, and the whole database will just dump out on your screen. It is pretty incredible. This is how Anonymous does it. You don't have to have any skills really. You just say you run an automated SQL injection tool, and it'll just dump out the data. Anyway, comes on TCP 1433, UDP, that's the Microsoft version of this. There's MySQL, the open source version. And the problem is, SQL injection works if the website designer was careless. It is not a vulnerability in the SQL Server, so it will never be patched by the SQL Server designers. Now, there are vulnerabilities occasionally in the SQL Server software itself, but SQL injection is not a vulnerability. It is the operation of it as designed, and it's up to the website designer to not design a sloppy website. It is a very common reason why security problems persist, because it's not my problem. It's not Microsoft's problem that your SQL Server got hacked by SQL injection. It would only be their problem if you got hacked by buffer overflow. And they passed the buck on to somebody who doesn't know what they're doing, but they went and took a SQL class and learned how to write websites. And they're doing just what they got an A in homework for. This is a fundamental problem. You have 2 or 3 people each doing a little bit of the job, not looking at the whole picture. Anyway, RDP lets you remotely control the Windows machine. Now that's basically what all hackers want. Remote desktop protocol. The point of this is it will package up the image on your desktop and transfer it to remote locations. So you can go home or to a hotel room and you can log in and remotely control your work machine with the remote desktop protocol. It is a limited licensed version of Citrix built into Windows 2000 Server and later versions of Windows products. So it's quite useful and considered a serious security risk. It had quite a few vulnerabilities. 43389 is what it runs on. It's blocked by a lot of firewalls these days. But of course, it's extremely handy. It's used by a lot of people to remotely control their Windows servers. Yeah.
It's not encrypted?
It is encrypted. And unfortunately, it has had a series of problems, security problems that let people get in anyway. But yeah, Microsoft did make an effort to secure it. I think it is possible to downgrade it to an unencrypted version. I know that's true of the old Windows 98 thing. PC Anywhere. PC Anywhere has been doing this job for a really long time, and PC Anywhere can be run with no encryption at all, which is a pretty bad idea. Yeah.
It would be a better idea to connect through a VPN and then an RDP?
Much better, yes. And that's what most companies make you do. They don't let RDP go directly through the firewall. They make you VPN in and then only local. That's much safer.
Okay.
You can also use third-party products like LogMeIn or TeamViewer that accomplish the same thing. And it's just up to your taste, because all those have bugs too. But on the other hand, if you're using a less popular product, there won't be as many automated attacks attacking you. So those are all, remote controlling machines is totally where it's at. I know guys that are administrators that told me about how they fixed the server by typing Unix commands on their cell phone in traffic. Because the alert came up, the server is down, tap, you know. And all the companies and major servers, they have to take teams like doctors on call. They have somebody takes the job for the next 36 hours of being on call, and at 2 a.m. your phone will go off and you have to get up and fix the server. Somebody has to have that job then, if you're a 24-hour business, and most people are. So a few more eye clickers. What you need is an authentication protocol. Kerberos, of course, it's named after the mythological dog that guards the gates of hell. This is the dog with 3 heads that bites you and stops you from going down the gates into hell if you're alive. So, which one of these is hacked by code injection? Did you guys have a question about the last one? Saw a hand go up. All right, anyway, so that is SQL Server. SQL in general. SQL injection is probably the #1 most dangerous website vulnerability right now, and has been for many years.